Okay, if we're looking at the sum formulas here and making u and v equal to each other, we sub in u for v. Alright, so we're going to do that everywhere. And the group that had sine, what did you guys come up with?
Well, sine of 2u or u plus u is equal to 2 times 2 sine u cosine u.
Good, okay. Multiplication is commutative, so sine u cosine u is the same as cosine u sine u, so you can add those together, and you get 2 sine u cosine u. And you're right, that also does equal the sine of 2u. Okay? How about the cosine of 2u? What did you guys come up with?
Cosine squared u minus sine squared u.
Okay. Did you do anything else with that?
Again, you got the next part.
I got it. You got it. Isn't it equal to...
So that's another you can do it.
Is that equal to 1 or negative 1?
No. What could we do?
Well, sine and cosine, sine squared plus 1 is...
Yeah, but
Isn't that equal to negative 1?
Hang on, you're on the right track.
Pythagorean identity.
Okay, Pythagorean identity, what could we do here?
Well, sine squared, or you can replace cosine squared of u with 1 minus sine squared of u.
Okay, let's talk about that. If we do that, we have 1 minus sine squared minus sine squared, so that equals...
1 minus 2 sine squared u.
2 sine squared.
Okay, good. Is there anything else that we could do? We replace the cosine squared with sine squared.
Replace the sine squared with cosine squared.
Yeah, there we go. What if we replace the cosine squared or the sine squared with the 1 minus cosine squared?
So 1 minus 2 minus 1 minus 2 cosine squared of u. 1 minus 2.
It'd be cosine squared minus 1 minus cosine squared.
What about the 2?
What does that simplify to? Oh no, I was going back to cosine squared minus sine squared. It'll work either way, but if I plug in a 1 minus cosine squared here, I get this. What does that simplify down to?
1 minus cosine
1 minus 2 cosine squared? Wait, no, sorry.
Negative 1 plus 2 cosine squared.
Okay, the 1 is negative, and we've got 2 cosine squareds.
But where are you substituting? Are you
You
substituting
went-
that?
We're
At the
substituting it
bottom.
right up there for the sine squared u. Okay? So we went back to the beginning. Alright?
So it doesn't matter which one you do. It's the same.
So there's actually 3 different versions of this same thing here that we could use. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. All of those would equal the cosine of u plus u, or cosine of 2u. Okay? Yeah, Kate?
I'm kind of confused. So we went from 1 minus 2 sine squared u. Where did the 2 sine squared u come from?
This came from when we put a 1 minus sine squared in for cosine squared. So we had 1 minus sine squared minus another sine squared gives us this. If instead we go back here and we put in a 1 minus cosine squared like we did right here,
You get equals 2
We get-
cosine squared u minus 1. So
Exactly.
both of those are possible answers.
both of those are possible answers,
Okay.
okay? Alright. Let's make that a little bigger. Okay? So we'll get rid of that so we just have the 1. The 3 versions that we want. Okay? Now, with tangents, what did you guys get that to come out to?
2 tangent of u over 1 minus tangent squared of u.
Okay? So we have a tan u plus tan u is 2 tangent of u over 1 minus, now it's tangent squared of u. Good, and that's tangent of 2u. Alright? So guess what we just did? We just derived our double angle formulas.
What's a double angle formula? Do we do that?
It's what we just did. If you have two of the identical angles added together, in other words, it's the angle times 2, then the sine of that double angle is 2 times sine of u cosine u. Or if you have the u and you double it and you take the cosine of 2u equals, in different situations, any of those three options might be useful, okay? We'll see that later. Tangent is 2 tangent of u over 1 minus tangent squared of u. Now the reason why I had you guys do that is, for one, to give you a little bit of an experience of what mathematicians do. You know, they get an identity and then they say, well, what if this were the case? And then they explore, okay? And that's how we get things like this. But also, it's so that, you know, anytime you try to memorize something, it's easier if you know where it came from. Kind of like when we did the Pythagorean identities, we started with sine squared plus cosine squared equals 1, and we derived the other two. Okay? Here, we started with the angle sum formulas, and we can derive the double angle formulas. Okay? So let's look at how we would use some of these. Alright? First of all, let's look at a type of equation that we haven't yet faced. And that is when we have not just different trig functions in an equation, but we have different angles in those trig functions. Here we have cosine of x, here we have the cosine of 2x. So we want to solve this for x. Now if we had one or the other, then it wouldn't be that bad. We've done those before, okay? But when we have a mixture of angles like this, the first thing that we need to do is we need to get this equation in terms of just one angle, okay? So, in order to do this, I would use my formula for the sine of 2x. And I've got 2 cosine x plus, what's the sine of 2x?
Can you make it 2 sine of x?
2 sine cosine.
2 sine u cosine u. That was what we just derived. 2 sine of x cosine of x. Okay? Now notice our equation only has x's in the trig functions now. Okay? Alright, so we're just using that identity that we just derived, 2 sine x cosine x. At this point, we're right back to the types of equations we've been solving. Okay? Do you have a question, Simone?
Can't we do something with the cosine or no?
What can we do with the cosine now?
And then 2 cosine squared?
No.
Like
Wouldn't
looking
it
at
be
it really
3
wrong.
cosine x?
They both have a cosine in there.
Well, isn't
Are they being multiplied?
Yeah.
isn't 2 sine cosine the same thing as sine?
Exactly, so
u
cosine
again?
squared.
Well, yeah, but we don't want to put that back in there. We just got rid of that. Hang on, I was talking to him.
Oh, sorry.
Oh, you subtract.
Divide?
Well, we don't want to divide. We'll lose roots. What can we do here?
Factor!
Factor. There we go. Factor. So, they have a 2 in common, and they have a cosine in common. Alright? They both terms have 2's, and both terms have cosines. Alright, so if I take that common factor out, what's left over?
2 sine x.
Plus 2 sine x.
1 plus
Sorry,
1 plus,
2c.
we took out the 2,
So it's just
2 sine x.
sine.
so it's just sine. 1 plus sine of x.
But like, how'd you take out cosine from 2 sine?
It's 2 sine times cosine. They're all multiplied together.
Oh, okay, I wouldn't.
Okay,
I mean, at this point, guys, it's kind of like factoring 2y plus 2zy, okay? You could take out a 2 and you can take out a y. Alright? It's the same kind of idea. Again, there's the connection between old algebra and what we're doing now with the trig. Okay? So now, guys, we know cosine equals something and sine equals something. What does cosine equal? 0. And sine equals -1, okay? So, where does cosine equal 0?
2 places. Pi over 2 and 3 pi over 2.
There we go. Pi over 2 and 3 pi over 2. Okay. Where does sine equal -1?
At 3 pi over 2.
At 3 pi over 2. Okay? 3 pi over 2. Cosine's -1 at pi. Alright, so we actually already have that answer. That's kind of nice. So we've got that as our final answer. If we're going from 0 to 2 pi. Okay?
Can you go over the factoring? I'm a little confused at where you took what from. If that makes sense what I just said.
Okay, so let's look at this. They both of these have a 2, right?
Yeah.
So we pulled a 2 out.
How can you factor it out if there's a plus sign there? It doesn't matter?
Well, if there's a plus sign, that's why we're factoring it out. Because they're added together. This is just like factoring, like I said, 2y plus 2 times z times y.
I see what you're doing.
I take a 2 out, and they have a y in common as well. And then you just have the 1 plus z left over.
I see, because that sine x times cosine x is one entity, one term.
Yes.
So that's where I wasn't seeing it yet.
Yeah. Okay. So we took out the 2. We took out the cosine, which we were allowed to do because it was all multiplication. And then all that was left, we took out everything from the first term, so you got to put a 1 in there. And all that was left of the second term was that sine. So let's try a different one here. We have 3 sine of x plus cosine of 2x equals 0. Now, again, we want to get this all in terms of the same angle. So we're going to use our cosine double angle formula. But we have 3 options to choose from.
You use 1 minus 2 sine.
Yes, why?
Because it's so that you have everything in sine.
There you go. Great. Okay. 1 minus 2 sine squared of x is what we'll use to replace the cosine of 2x, because our other term has a sine of x, and now everything will be in terms of sines.
Oh, so that's why we would use all the different ways to change cosine of 2u depending on what our other. Okay.
Yeah, depending on what our other stuff is and what we were trying to do, we might have used cosine squared minus sine squared, or 2 cosine squared minus 1. In this case, 1 minus 2 sine squared is the most useful. Okay? So, actually, yeah, at this point we've got a quadratic. We need to put that in order. -2 sine squared x plus 3 sine x plus 1 equals 0. You could try to factor this, but it actually won't. Okay? So what do we have to do? Quadratic formula. So why don't you take a minute and try to finish this one off yourself. Alright, so if you do your quadratic formula, you should get the sine of x equal to a -0.280776 or a 1.780776. Okay?
Which one is the plus root 17 and which one's the negative?
the plus root 17 gave us a negative answer, and the minus gave us a positive answer. Because that denominator was negative, that's what ended up.
Well,
Good
doesn't
for
the
us.
two negatives cancel out?
Yeah, that's why when we subtracted this root 17, we got a positive value at the end.
So we can just simplify it to be 3 plus radical 17 over 4, or 3 minus radical 17 over 4.
Yeah, -3, but yes. Okay?
Well, doesn't negative 3 over negative 4 come out to just?
Well, but you've gotta add or subtract the root 17 before you do the divided by 4, okay? So at this point here, we do our inverse sine,
4, 6. Wait, are you sure you're in radians?
okay? We do our inverse sine, what do you get?
Negative 0.28460225. Yeah, or should I go slower?
Wait, you're doing the inverse of find x?
Wait, which one? Which one did you do?
Find the angle.
Well,
Which one
you
did
tell
do?
me.
Oh yeah, we can't do the negative one.
We can't do, well, which one can't we do?
Wait,
The positive one because it's bigger than 1.
Yeah, this is bigger than 1. We can't have a sine equal to something bigger than 1. Alright?
You just make
So
it
we
0.7
got-
though?
So you get negative
Huh?
0.284.
Well, they're
No, you can't just make it 0.7. That just
Wait,
is
are
a
you
value
doing
that.
radians or degrees?
Right now it didn't really matter which one you're in, but we will use radians here. But either way, sine cannot be something bigger than 1, okay, or smaller than -1. So we can eliminate that choice. So now we have the 0.280776 that's negative, and we do the inverse sine of that. Okay. .280776 negative, and I do the inverse sine. What are you guys getting for that?
Negative 0.284046.025.
2846.
02.
02, okay. So now at that point,
Wait, did you do the inverse of sine negative 0.28?
Yes.
Yeah.
I know, I thought it was the same thing.
You get 0.2846.
Yeah.
yeah, you get that, negative .28460254. Okay, now, the couple of things here that we should do. First of all, what quadrant is that in?
That is it. Fourth quadrant.
That's in the fourth quadrant. Okay, now if we're asked to give answers from 0 to 2 pi,
We have to add.
Wait, how did you know it was in the fourth quadrant?
well, because it's negative.
So, but it could be in the third one as well, right?
That's true, so let's divide by pi. And we see that this is actually a negative 0.09059 pi. Okay?
And so could you just
If we divide by pi, then you can write it in terms of pi, and it's a little easier to see what quadrant it's in.
Would you just add 2 pi to that and then down
Yeah.
there do your reference angle and you could figure it out from there?
Yeah, now
I think right
here,
angle, sorry.
it would give you your actual
Yeah.
angle in the fourth quadrant. Now, be careful, if you divided it by pi, this is just the coefficient of pi, so we would just add 2 here,
And just don't even.
and leave it in terms of pi. That's
Why would you add
So
2?
1 point.
gonna be 1.9094 pi.
You're adding 2 pi, so you do a whole circle so it gets out.
Alright, so let's look at another application that we could use here. Okay. We've dealt with situations similar to this, where we were given the cosine of an angle, we were told that the angle is in the fourth quadrant, and we were asked for the other 5 trig functions of that angle. Okay? I mean, in fact, with this one, notice, since they already drew the triangle for us, it's nice. We have 5 and we have -12. So we could very easily, find sine of theta. What's sine of theta in this case?
2 times.
Negative 12 over 5.
Yeah, negative 12 over
13.
13, opposite
Yeah.
over hypotenuse. Okay? What would tangent equal, Ethan?
Negative 12 over 13 over 5 over 13.
True.
So, negative
Which
12
is-
over 5.
There you go. That's negative 12 over 5. Okay? And we could find the other three trig functions as well. But what if instead of just doing theta, what if we wanted to go around theta, but then around another theta?
That's 2 theta.
That would be 2 theta. Okay? So we have 2 theta. Now, we end up in the third quadrant here. But, you know, what's the sine, cosine, and tangent of that? This is where we have to use our identities.
So,
Our double angle formulas, okay? So, what's the formula for sine of 2 theta?
Wait, what's the
2,
blue
2
line?
sine cosine.
What's the blue line going that direction?
Because it's 2 theta. So,
How many?
instead of going, it'll go a whole other 360 degrees around.
So, we actually already figured out what sine of theta is, okay? But we have here 2 times negative 12/13 times the 5/13 that we were given. So we now have a negative 120 over 169. Okay? How would I find cosine of 2 theta?
which one would be the most beneficial to use?
Yeah,
Or
I'll
even
get
the-
one.
Since we already figured out sine, we could use either of them. If we just wanted to use what we were given,
1 minus sine squared of 2 of theta.
or you could do that as well, yeah. But you'd have to square root it, okay? But yeah, we could do 2 times the cosine squared minus 1, alright? And we'd actually end up with 119, negative 119 over 169. And then how would we find tangent of 2 theta? Yeah, sine of 2 theta over cosine of 2 theta. Or we could use the double angle formula for theta, either one, or for tangent. So this is negative 120 over 169 over 119 over 169. The 169's cancel out, and I have 120 over 119. Okay? Alright.